section in our chapter of this study of the seas here is the actual geographies of the sea. One thing that is mentioned right away here in the first paragraph there is the term ocean basins. And ocean basins are the deep depressions in the Earth's surface that contain the oceans. Until modern times, most scientists assumed that the ocean basins were relatively smooth and featureless. With the advent of actual study of the ocean floors, we've realized that that is definitely not the case. There are places that are smooth and featureless, or relatively featureless, but there's actually a lot going on down there. The first general area here is the continental margin. We'll see this term again at the end of this chapter, kind of not the end of the chapter, end of this little section, kind of tying everything together. The first part of the continental margin is the continental shelf. This term is found on page 171. It's described as a gently sloping underwater plain. So it's not flat, it's just, it is sloping, but it's a very gentle. It's not very steep, and it moves, I guess you could say it goes kind of slowly. This borders the coasts of the continents. Every continent has these continental shelves. How far they stick out, how smoothly they slope, depends on where we're looking. We see a lot of undersea life here. It just abounds with undersea life. If you've ever been to the coast, you've seen how much life is at the coast. When I lived in Florida, I was told that if you ever take a helicopter ride over the coastal areas, you will never go in the ocean again, because you'll just see how much life is in that area, including sharks, manta rays, jellyfish, all sorts of things, both cool and kind of scary. Near the edge of the shelf, actually kind of a boundary on the continental shelf there, is the actual shelf break. This is the sharp drop-off at the edge of the continental shelf. You can almost think of it as an undersea cliff. And the shelf break is that boundary between the continental shelf and the continental slope, our term number 3 here. This is where the seafloor drops away from the continent abruptly. Actually, the continental slope is the actual cliff. The shelf break you could think of as more of the edge right up at the cliff, at the top of the cliff. So this is really close to the coastline here, what we would consider the coastline. And then at the bottom of the continental slope, or right at the edge of that, the bottom edge of that is the continental rise. This is a gently sloped region at the base of the steep continental slope. Now in the picture here, it's a steep drop-off. It's not so much of a cliff in this picture. It's just a steep drop-off. And remember that term continental margin, which we started this one with? That's the whole region, from the continental shelf, including the continental break or the shelf break, the continental slope, and the continental rise. This is all called the continental margin. And you can see there is a term right here at the very bottom of the page. I kind of snuck it on there. Submarine canyons. And these are they are exactly what they sound like. Large underwater fissures. We find them in the continental rise area of the ocean. Not so much the continental shelf. Well, actually, it's a little bit maybe in the continental shelf, because some of them seem to be continuations of present-day rivers, and the location of some of those rivers might end right at the continental shelf there. So our book mentions the Hudson River Canyon, which basically extends from the Hudson River out into the ocean underwater. So yeah, it could be. See, our book describes it as these cut through the continental shelf, these submarine canyons. I think I got my continental shelf and continental rise mixed up earlier. The submarine canyons cut through the continental shelf area, which is where we'd find the end of rivers. And some of them look like they just are continuations of rivers. Again, if we consider the flood in Genesis and where rivers are that we can see today or that we know about, we can dry riverbeds and such. It just seems like an extension of that. And if the water levels were lower at one point, and with the water rushing off of the continents, it could easily lead to these canyons that we're discussing. After that, we get to the deep ocean floor, the abyssal plain or abyssal plain. This is a relatively level region of the ocean floor at the base of the continental rise, an average depth of around 14,760 feet below sea level. Now, on the abyssal plain, we can find sea mounts. These are underwater mountains, underwater volcanic mountains, and they don't get the name seamount until they're over 3,200 feet. Excuse me, let's try that again. Over 3,200 feet above the sea floor. They're still underwater. They're not necessarily above water, although some of them could eventually get there. Hawaiian Islands are a great example of that. But once they're 3,200 feet above the sea floor, they're considered a sea mount. Kind of a different type of seamount, I guess we could call it, or around seamounts actually, are atolls. These are circular coral reef islands that grow around seamounts. Sometimes they will stick above the water, forming a land area, but the coral part stays underwater. They might grow for other reasons. A lagoon is a pool of shallow, salty water often found in the center of an atoll. So, and we have a diagram here. We can see kind of like a cutaway here. As it grows up, coral islets that are getting above the water level there, and the lagoon in the middle. Another underwater feature attached to these seamounts, really, mid-ocean ridges. These are underwater mountain range. Think of like the Rockies, except completely covered in water. The Mid-Atlantic Ridge is one of the most widely known underwater mountain chains, and it splits right down the middle of the Atlantic Ocean, almost as if it's like a seam on a baseball. You'll kind of see it in the next slide when I have a picture of several of these ridges. A rift is a huge valley where the crust appears to be separating, often found in these mid-Atlantic or in these mid-oceanic ridges. Most scientists believe that the ocean floor is slowly spreading at the mid-ocean ridges at the present rate of about 2.2 inches per year. Find this on page 183 of your book. This should be a picture. You can see these dark lines in the middle of the oceans there. These are mid-ocean ridges. The Mid-Atlantic Ridge is right here. Here. That's the Mid-Atlantic Ridge. We can see some other ridges around here as well. So, yeah, it's almost like the Earth has seams, really, with these mid-ocean ridges. The Hadal Zone, I believe I'm saying that right. Where'd it go? There it is. The Hadal Zone, yep. These are great depths. Any area of the sea that exceeds 6,000 meters in depth. Found in these places are trenches. These are huge muddy valleys cut through portions of the abyssal plain. So these are deep water trenches, not to be confused with submarine canyons. Remember, those were on the continental, they were in the continental margin there. The deepest known point in the sea is Challenger Deep, located in the Marianas Trench near Guam. I have a picture of that here showing where that is located. Approximately, it's not, I mean, it's big. Scale isn't quite right. And that is actually it for section 6.3. There are a few other details we'll go over in class, but your question for this one is going to have to do with seamounts. So that's what your science video question is going to deal with on this one, and that is seamounts. So make sure that you were paying attention there.